Now, our next topic is periodicity in properties. Now, what do you mean by periodicity in properties? A repetition of properties of elements at regular intervals of time is called periodicity in properties. And what is the reason for this repetition of properties of elements? The reason is due to similar outer electronic configuration. So, let us discuss each property in detail. The first property is atomic radii. 1. Atomic radii. What do you mean by atomic radii, or it is also called atomic size? Means the size of an atom. Now, how will you measure the size of an atom? Atomic radii is the distance from the center of nucleus to the outermost electron or outermost shell containing electron. That is atomic radii. Now, let us see the variation of atomic radii down the group. How does atomic size or atomic radii vary down the group? Now, you know that down the group the atomic size increases or atomic radii increases. Atomic radii increases down the group. Now, what is the reason for this increase in atomic radii down the group? You know that down the group the number of shells increases, that is n value increases down the group, isn't it? Then the force of attraction, when the number of shells increases, what happens? The force of attraction on the valence electron by the nucleus decreases, because as the number of shells increases, the electron will be farther away from the nucleus. If it is the first period, n is equal to 1, second period n is equal to 2, third period n is equal to 3. So, down the group n value increases means electrons are being added to higher n value, means higher n value means the orbit is farther away from the nucleus. So, the electron also will be farther away from the nucleus. So, the force of attraction on electron by the nucleus decreases. Now, also we know down the group atomic number increases. Atomic number increases. So, the nuclear charge increases. Atomic number means the number of, it is equal to the number of protons, and we know that protons are present inside the nucleus. So, nuclear charge means the positive charge of nucleus increases. But that effect of increase in nuclear charge is less compared to the screening effect by the inner electrons. We know that when you come to the last elements of the periodic table, we have the d and f orbitals getting filled. So, what happens? There is screening effect by the inner electron. What do you mean by screening effect by inner electron? That inner electrons will not allow the outer electrons to get attracted by the nucleus. So, there is a screening effect also. So, that screening effect is more compared to that increase in nuclear charge. So, what happens if screening effect is more? Screening effect more means that inner electrons will not allow outer electron from attraction with the nucleus. So, the outer electrons are less loosely held, or we can say the effective nuclear charge Z effective decreases. So, what happens when Z effective decreases? The atomic radii increases or size increases. Okay, so this is the reason for the variation of atomic radii down the group. Down the group, what happens? The number of shells increases, atomic number increases, but the increase in nuclear charge is less than the screening effect by inner electron. So, Z effective decreases, so atomic radii increases. Now, next let us see the variation of atomic radii along the period or across the period, variation across the period. Now across the period we can say atomic radii decreases. When you move along the period, the atomic radii decreases. Now what is the reason for this? Across the period, you know that nuclear charge increases because atomic number across the period, if you see the periodic table, you can see atomic number 3, 4, 5, 6, it increases by 1 unit. So nuclear charge also increases by 1 unit. Now the number of shells remains the same across the period because you can see here n value remains the same. Second period n value is 2. It remains the same and electrons are added to the same shell, and when you move from each element to the other, the electrons, one electron is added to the same n value. Now force of attraction between nucleus and valence electrons increases because electrons are added to the same shell. So effect of increase in nuclear charge is more compared to the screening effect. So Z effective or effective nuclear charge increases means atomic size decreases. So what is the reason for the variation of atomic radii along the period? Along the period we can say atomic number increases by 1 unit, so nuclear charge increases by 1 unit. Also n value remains the same or number of shells remains the same, electrons are added to the same shell. So force of attraction between electron and nucleus increases, and here the effect of increase in nuclear charge is more than the screening effect by inner electrons. So Z effective increases, atomic radii decreases. Now next let's see about ionic radii. Ionic radii. Now ionic radii means the size of the ions. You know we have cations as well as anions. How is a cation formed? Cation is formed by the loss of electron. We get a positively charged ion called cation, and an anion is formed by gain of electrons, and that's a negatively charged ion. So we are going to discuss about the ionic radii. We are going to compare. So we will study this as a question. The first question is the radius of cation. Radius of cation is always smaller than or less than its parent atom. Or I will give you an example. The radius of Na plus sodium ion is smaller than, who is the parent atom of sodium ion? Sodium atom. Why? Now you know that cation means it is formed by losing one or more electron. So number of electrons decreases, but you know that there is no change in the number of protons. So since there is no change in the number of proton, we can say nuclear charge remains the same. Okay, so the number of electron is less, but nuclear charge remains the same. So what happens? The force of attraction by the nucleus on the electron increases. Z effective increases and ionic radii decreases. So this is the reason for the smaller size of cation compared with its parent atom. Okay, now next question. Radius of anion is greater than its parent atom. Now, or you can say anion, for example, Cl minus, Br minus, F minus, I minus, size is greater than parent atom of Cl minus is chlorine. Now, how is an anion formed? Anion is formed by gaining one or more electron. So what happens? The number of electrons increases and nuclear charge remains the same. No change in nuclear charge. Now the number of electrons is more here. So what happens? Addition of electron will result in electron-electron repulsion. So force of attraction from nucleus on the electron decreases. Z effective decreases ionic radii increases or size of anion increases. Okay, now next let us see if there are cations of different charges, then we can say that a cation with higher charge has smaller size, or we can say as charge on cation increases, size decreases. For example, you take the cations Al3 plus, then Mg2 plus, then Na plus. Now, if you are asked to arrange in increasing order of ionic radii, increasing order means small to big with less than sign. So, we know that as charge on cation increases, size decreases. So, who has the maximum charge? Aluminium. So, in increasing order, if you are asked to arrange, you will arrange it as Al3 plus less than Mg2 plus less than Na plus. This is the order, increasing order. Okay, now next rule is on the basis of anion size. As the negative charge on anion increases, size increases. Now for example, or I will write on the board, as negative charge on anion increases, size increases. So, if you are asked to arrange F minus, O2 minus, N3 minus in increasing order of their ionic radii, you can say as charge increases, negative charge increases, size increases. So, if you are asked to arrange in increasing order, you have to write from small to big. So, which has the smallest size here? F minus. So, I'll write as F minus less than, next comes O2 minus less than N3 minus. So, this is the order of arranging the anions in increasing order of their size. Now, I'll discuss one question. Arrange or which of these species, that is Mg, Mg2 plus, Al, Al3 plus has the largest and smallest size. Now we know that we have the parent atom and the ions given. So we know that a cation with higher charge has the smallest size, or a cation size is smaller than its parent atom. So here we have two cations. Aluminium has the highest charge. So which has the smallest size here? Al3 plus has the small size among these species given. And which has the largest size here? Size of parent atom is greater. So when you compare magnesium and aluminium, magnesium is in group number 2, aluminium in group number 13, and we know as we move along the period, size decreases. So which has the highest size here? Magnesium has the largest size. So with this we finish the first periodicity in property, that is the first property, that is atomic and ionic radii. Thank you.